that worded in the book, that problem?
It says, calculate the average mass of one iron atom in grams.
Okay, notice how there's extra fluff in there? I mean, it's not quite as concise as that, so again, go back and look at the book, because test A is probably going to be more similar to the book. All right, so what have we got? We have one atom, and we want to know how many grams that is. One atom. I mean, we really can't go pick up one atom, but we can do it on paper. Okay, so what, if you think about it, on this mechanical approach, you're right here. And we want to get way back to here. Well, we can do it. Okay, we got one atom. You got atoms. In this case, only one. We can get to moles of the stuff. And if I can get to moles of the stuff, I can get to grams of the stuff. Okay, so let's get it started. One atom of iron. And if you wish, just to be safe, you can always put that over 1 to keep numerators and denominators straight. Okay, now, our next trick. I can do this 2 ways. I can say 1 mole is 6.02 times 10 to the 23rd atoms. And that would be similar to Chapter 1, where we're very carefully doing a unit analysis. An alternative. We have this 1 atom of iron. And see, this told us, go divide by Avogadro's number. If you could handle complex fractions, you could do it this way. 6.02 times 10 to the 23rd atoms per mole. This or these 2, take your pick. But do you see what happens here? And I usually do it this way just to save some writing. Atoms here cancel with atoms here, complex fraction, moles come around on the top. Or here, it's easier, atom and atom, moles is already up there on the top. Okay, now, we don't need to stop there because we know we've just made it to moles. I'm at moles. How do I get on? What do I do next? Emily, what do I do next?
Multiply.
By? Okay, look over here. We're multiplying by the atomic weight. And what are you working with? Iron. So where are you going to get the atomic weight of iron? Yeah, periodic table. Can you see it from there? Okay. 55.8. Why don't we say 8.5? We used 4.6 before. Take your pick on this. I would count this, the 1, as an absolute number, just like there's 1 person in that seat. I mean, I know there's 1 person in that seat. So in this problem, we know we have just 1, not 1.5 or 0.9 or something. So, and that's going to be grams per 1 mole. Now, if I keep it running up here, it might be a little bit clearer to you. But it's grams per mole for your atomic weight. So here we have, remember how moles came around on the top? Moles are on the bottom, leaves us with grams. And so, multiply these across, and we get that 55.85. Multiply these across, and of course it doesn't change the value, but divide the bottom into the top. And I'll let you pick SIGs on that, so let's punch that through. Prashant, do you have a number for me?
I got it 9.277.
And the units are?
Gram.
Yeah, just plain old grams. Yeah, Nikki.
See, that's what I got too, but then in the book it says is like 6.022, so you get 9.274.
No sweat.
Okay,
Okay,
so
do you see the point Nikki's making? In the book, they're using 6.022. I mean, go ahead if you want to. Your answer's going to be just a trifle bit different. The test is multiple choice. Pick your closest answer. I was just thinking, when you memorize Avogadro's number, just the fewer digits to have to recall, the easier it's going to be. Most of the problems in this book either go for 3-6 or 4-6. Probably 3 more often than 4. And we got a really tiny number, which is what we expect. Something to the -23rd. Now, everybody comfortable with that?